Hello friends, I welcome you all to watch my new video of class 12 physics, and in this video we are going to discuss a very important topic of Gauss Law. And the statement of Gauss Law says that the total electric flux passing over a closed surface in a medium is always 1 by epsilon naught times of the total charge inside the surface. Okay, and the net flux is equal to the integration of the closed surface E dot ds. ds is the small area element, and this will give you net charge inside the closed surface upon epsilon naught times. Okay, and here value of epsilon naught is 8.85 into 10 raised to minus 12 coulomb square per Newton meter square. Okay, so for sake of convenience, here you can see that we have assumed this is a small area element ds. Okay, this is a closed surface, and a positive charge plus q has been placed at the center, and due to this positive charge there is electric field which is radially outward, which has been shown like this. And this is the, as you know, that area vector is always perpendicular to the surface. Okay, this is the basic criteria, and this is the electric field. So electric field is also here radially outward. Okay, so you can see that between E and A, okay, between E and A, angle is 0 degree because they are parallel. Okay, both are in same direction, so angle is 0 degree. Okay, so if you would like to prove the Gauss law, what it is, that you already know that if closed surface integration E dot ds, here ds is the small area element we have taken. To prove Gauss law, you know, this kind of surface we just generally keep a small area element, and if we integrate all those small area element, then we will get the required area, okay, total area, and we will easily get that how much, what is the total area, and what is the total flux passing through that area. That will give you the resultant electric field. So if you will see here, integration E dot ds. Okay, you are integrating electric field and the small area element dA. So what will happen here, if you will break, this is E dot ds, and this area this is a cos 0 degree because angle between E and A is 0 degree. Okay, now this will E, since E is constant, so you can place this E outside this integration, and this is ds. Okay, this is the small area element which vector means which is radially outward. Okay, now as you know, this is a closed surface, and what is the total area of this closed surface is nothing but E into 4 pi r square. What is your E? What is your E? E, you already know that this is, here you can see, electric field value is 1 by epsilon naught times into q upon r square. Okay, so if you put this here, okay, this is ds, integration of ds, area of the circle. Already you already know that this is the 4 pi r square, and this gives you electric field value is q upon 4 pi epsilon naught r square. Okay, and this term 4 pi r square, so 4 pi r square got cancelled, and you simply left with you left with only is that total flux. This equation gives you total flux, okay, net flux inside is q upon epsilon naught, and I can say this is total net flux, total net charge inside the closed surface. So this will gives you the proof of Gauss law, this equation. Let me explain one more time. This is integration of ds. We are integrating this area, electric field, and the small area element ds. Okay, so what is E? E is, you already know that 1 upon 4 pi epsilon naught into q upon r square. So this, and this is a circle. So what is the total area here? Is 4 pi r square. So if you will put the value of E and the value 4 pi r square got cancelled, and you simply left with q upon epsilon naught, which gives you nothing but net flux inside, net flux, total net flux, and passing through that closed surface, and this gives you q total net charge inside the closed surface upon epsilon naught. Okay, this is epsilon naught. Okay, so this is the proof of Gauss law. So now we will discuss some important points of Gauss law, and the point 1 says that as you can see that charge is same in this circular area, and this is your cubical face, and here also the charge is same, and here you can say any closed surface. Okay, and in that we have placed a charge q at the center. So as you can say, the same charge has been placed in all the three surfaces, and as you know that this point says that means if the charge is same, okay, then total electric flux, okay, phi 1 is passing through this, phi 2 for this, this one is the net flux, and phi 3 for this. So if total charge is same in all the three area, then total electric flux passing through those closed surface will always be same. So this is point number 1. Now we will see point number 2. Now we will discuss the very important point of Gauss law, and if this law, this point says that for any closed surface, okay, the charges lies inside will contribute to the total flux passing through that closed surface, not the outside charge of this closed surface. This is very important point. So if you can see that q1, q2 and negative charge q3 is placed inside the closed surface, while minus negative charge q4 and q5 is outside of the closed surface. So to calculate flux, we have simply assumed the flux total charge inside, that is q1 plus q2, and here this is negative sign, so we have taken q3 upon epsilon naught. So to calculate total flux passing through that closed surface, we will consider only the charges present inside the closed surface. So this is point number 2. Now we will see point number 3 of Gauss law. Now we will discuss one more properties of Gauss law, and this is very important. And as you can see, this is a cubical surface, and a charge q has been placed at the center of the cube, and this law says that if the total electric flux, okay, through this closed surface is q upon epsilon naught times, okay, then if you have to find out flux passing through any surface, then it would be 1 by n times of the total net flux, okay, where n is the symmetry, means number of symmetrical faces. It has 8 faces, so it will be we can see that it has n symmetrical faces. Now to simplify this point further, I have written here, if you can see, if there is any closed surface with n symmetrical faces, electric charge has been placed on the center of the closed surface, okay, Q, then the electric flux passing through any one surface of the closed surface will be 1 by n times of the total electric flux. So here, according to Gauss law, the total net electric flux is Q upon epsilon naught times. And if you have to find, suppose if I name it this surface, okay, this surface of the cube as 1, then total flux passing through this surface will be 1 upon n times of the total net electric flux, okay, and total net electric flux can be written as 1 by n, and net flux can be given as Q upon epsilon naught times. So this is very important topic of Gauss law, and you already know that you have to keep certain points in mind while calculating, while deriving Gauss law, okay. So Gauss law says, Gauss law generally depends upon 3 factors. If you can see, phi is E a cos theta, okay. So this depends upon 3 things: the electric field, okay, and the area vector, it's a vector quantity, and the angle between electric field and area component, okay. And flux will be a scalar quantity, because here electric field and area both are vector. So you already know that product of 2 vector quantity gives you a scalar quantity, and so your flux will be a scalar quantity, okay. Thank you. Thanks for watching this video, and please do like and subscribe, and please do share this video with your friends, okay. Thank you. Have a nice day, and happy learning.